Alright. So in today's session, we will be discussing about Mason's rule. I think we will revisit our control systems a little bit because all our amplifier stability circles or amplifier stability relationships will be derived using Mason's rule. So it is important that we have a basic understanding of Mason's rule before we go on to amplifier stability conditions. So the basic Mason's rule goes like this. You have a loop like this. Let's say I have a loop like this, and the transfer function of the loop is given by the equation sigma pk del k by del. So transfer function is equal to sigma pk del k by del. So what is pk? Pk is the gain of the forward path. Pk is the gain of the forward path, and del k is 1 minus gain of individual loops I could say that does not touch the forward path. Gain of the individual loops that does not touch the forward path. And this del is nothing but 1 minus gain of the individual loops plus gain product of 2 non-touching loops minus gain product of maybe 3 non-touching loops, and it goes on. The equation goes on. Alright. So del is equal to 1 minus this del is equal to 1 minus gain of individual loops plus gain product of 2 non-touching loops. So let's do this Mason's rule, and then we will be able to understand this concept better. So let's solve for this loop. I have a loop like this. Now the first thing that we need to calculate is the forward path, the gain of the forward path. So how many forward paths do we have? This is the output and this is the input. So how many forward paths do we have between output and input? So we have 1. This is forward path 1, and there is another path 1, 2, 3, 4. Look at this. This is forward path 1, 2, 3, 4, and this is another forward path. So we have totally 2 forward paths. Look at the other paths. All these paths go back. They don't go forward. So there are only 2 forward paths. So let's write down the 2 forward paths. What is pk? Pk is the gain of the forward path. So let's write p1, the gain of the first forward path. P1 is nothing but A12, A25. A12, A25. This is the gain of the A12, A25. This is the gain of the first forward path. Now let's look at the second forward path. A12, A23, A34, A45. So P2 is equal to A12, A23, A34, A45. This is the gain of the second forward path. Now let's move on to the next one, del k. So because we have 2 forward paths, we will have 2 values of del here. So first let's find out del 1. What is del k? 1 minus gain of the individual loop that does not touch the forward path. 1 minus gain of the individual loop that does not touch the forward path. So let us look at an individual loop that does not touch forward path 1. What is the forward path 1? A12, A25. Is there any which does not touch, any loop which does not touch the forward path 1, A12, A25? How many loops do we have? We have first loop, say this is one loop. So this is a loop, it is touching this forward path. This is the second loop. Is it touching the forward path? No. So we can write this loop as del 1 will be nothing but A34, A43. A34, A43. So this is the only path, or there is another closed path. Look at this fellow, but it is again touching this forward path A12, A25. So del 1 is equal to A34, A43. Now let us see if there is any closed loop. If there is any closed loop that is not touching forward path 2. What is the forward path 2? A12, A23, A34 and A45. And how many loops are there? This is one loop, this is another loop, this is another loop, this is another loop, but all the loops are touching the forward path 2. Am I right? See, this loop is touching this forward path, this loop is touching this forward path, this loop is touching this forward path. So del 2 will be 1. Del 2 will be 1. So we are done with the numerator. Now let's go to the denominator. Denominator del is equal to 1 minus gain of individual loops. How many individual loops I have? I have 1, this is loop 1, this is loop 2, and this is loop 3. They also have another loop. Look at this fellow. 2, 3, 4. So I have totally 4 individual loops. So individual loop 1, what is the gain of the individual loop 1? A23, A32. Individual loop 2, A34, A43. Individual loop 3, A45, A54. And what is the loop gain of this fellow? Look at this fellow, IL4. Individual loop 4 will be A25, A54, A34 and A32. This is also an individual loop, right? Look at this fellow, A25, A54, A43 and A33. It starts and ends at the same point. So this is also another individual loop. But we cannot say this as an individual loop. Look at this. Suppose if I say 1, 2, 3, 4, this cannot be an individual loop. Let's say this fellow, 1, 2, 3, 4. Can we call this as an individual loop? We cannot do this because look at this node. It is entering and it is leaving. Second time it is entering and it is leaving. So the loop, if you consider a loop, it should enter the node and leave the node only once. But here it is entering twice. See, look at this flow. It is entering here once, it's going, it's coming, and then it is entering another time. So we cannot consider this as a loop. Whereas this flow, it goes here, it is entering into the node once, it is leaving the node. It is entering into the node once, leaving the node. Entering the node, leaving the node. So this can be considered as a loop. So we have totally 1, 2, 3 and 4 individual loops. We have 4 individual loops. It doesn't stop here. What do you have? Plus gain product of 2 non-touching loops. Are there any 2 loops that are not touching each other? Look at these 2 fellows. Look at loop 1 and 3. They are non-touching loops. So gain product of non-touching loops. What is that non-touching loop? A23, A32, A45, A54. This is the gain product of the non-touching loops. Now let's write the transfer function of this entire system. The transfer function is equal to sigma pk del k, which is nothing but p1 del 1 plus p2 del 2 by del. p1 del 1 plus p2 del 2 by del. What is p1? A12, A25. What is del 1? A12, A23, A34, A45 plus what is P2? P2 is A1. Oh, I made a mistake. Del 1 is A34. Del 1 is A34, A43. Del 1 is A34, A43 plus P2 is A12, A23, A34, A45 into what is del 2? Del 2 is 1 by what is it? Del. What is del? 1 minus gain of individual loops. 1 minus gain of individual loops. So this is the gain of the individual loops. So let's write the gain of the individual loops. 1 minus gain of the individual loop. What is it? A23, A32 plus A34, A43 plus A45, A54 plus A25, A54, A34, A32, 1 minus plus gain product of 2 non-touching loops. These are the gain product of 2 non-touching loops. I will have A23. This is the gain product of 2 non-touching loops. A23, A32, A45, A54. The gain product of 2 non-touching loops. So this is your Mason's rule.